Next problem, called uneven growth example. So there are no blanks here, no skip dividends. The first dividend that you would receive is $1 in 1 year. The next one is $2 in 2 years, then $3 in 3 years, then $4 in 4 years. After that, you expect the company to grow at 7% per year indefinitely and adjust its dividends accordingly in order to reflect its earnings. The required rate of return is 12%. What is this company's stock worth today? Okay, so let's start with the timeline and put all the information we are given on it. So essentially we have 2 time periods. For the first 4 years, we have a so-called non-constant growth dividends. After that, after the 4th year, we have a constant growth dividend pattern. So why is the first 4-year time period called non-constant growth? Well, look at the dividends that we are given. $1 after the first, at the end of the first year, $2 at the end of the second year, then $3, then $4. What is the growth rate when we go from $1 to $2? It's 100%, right? So we add another $1, another 100% of the original $1. What is the growth rate going from $2 to $3? Is it the same 100% growth rate? No, we don't add another 2. We only add another 1, right? To go from $2 to $3. So it's actually a 50% increase in the dividend. Then going from $3 to $4 is again a different growth rate in dividends. We're actually adding $1 again, which is 1/3 of $3. So it's a 1/3 growth rate, or 33.33%. So see how the growth rate changes from 100% to 50% and then to 33.33%. That's why it's called a non-constant growth time period. After the 4th year, what we are given in the problem is that the dividends will then be growing at a constant rate of 7% every year in perpetuity. So can you figure out how much the dividend will be at the end of the 5th year? Yeah, just take $4 at the end of the 4th year and multiply it by 1 plus 0.07, right? We are increasing it by 7%. The same way you can then find the next dividend at the end of the 6th year. You just add the power 2. So $4 times, open parenthesis, 1 plus 0.07, close parenthesis, power 2, and so on. So the dividends will be growing, right, at the same 7% annual rate, indefinitely, in perpetuity. Now, how do we find the present value of all of this? There's like a lot of stuff going on, right? First, let's look at which part of these dividends is similar to what we had in our previous problems. That's right, we have a growing perpetuity, just like in our last numerical example. So let's start with that. We have a growing perpetuity. $4 is the first cash flow, which is then increasing by 7%. So if we apply the present value of a growing perpetuity formula to these dividends, with the first one being $4, it will again give us the present value of it all 1 year before the first dividend in this endless sequence. So it gives us basically the present value of this growing perpetuity at the end of the 3rd year, counting from today. Right? So there's a 1 year gap between where our first dividend is and for which year we find the sum of it all. So we put $4, the first one in this endless growing dividend sequence, $4 in the numerator, and then we divide it by the difference between the 12% discount rate and the 7% annual growth rate in dividends. And that gives us $80. Now think of what we have just done. We have simplified everything that was given to us to the following. In 1 year, you get $1. In 2 years, you get $2. In 3 years, you get $3, and it's as if you're also receiving $80. And there's nothing after the 3rd year, nothing at all. Whatever there was, it's now included in $80, right? And now the whole problem is not too bad. It's simplified significantly. How would we find the combined present value of these essentially 3 different cash flow keys, right? You can do it by hand. Discount $1 back by 1 year by dividing it by 1 plus 0.12, right? The same discount rate we used earlier for the growing perpetuity present value, plus $2, which is in 2 years, discounted back by 2 years. So $2 is divided by, open parenthesis, 1 plus 0.12, close parenthesis, second power. And then we add the third and last term, which is a total of $83, right? Discounted back by 3 years. So we divide it by, open parenthesis, 1 plus 0.12, close parenthesis, power 3. And when you do the math, essentially each term one at a time, write down the numbers and then add them up, you will get $61.57. That's the price you would pay for 1 share of stock today. That would pay you back $1 in 1 year in dividends, $2 in 2 years in dividends, then $3, then $4, and after the 4th year, the dividend would be growing by 7% in perpetuity. So this is how you would do the second step. But again, I want you to use the same solution as in our previous problem. In our previous problem, we also had the growing perpetuity, right? And then remember what we did in the second step. We actually were able to solve it using the cash flow keys. So let me show you how you would use the cash flow keys in this problem. First, let's clear the calculator. Cash flow button. Cash flow 0 means the dividend you would receive right away if you buy the share. There is nothing, right? So you save it as $0. Press enter. Down arrow key. Cash flow 01 means the first dividend in the future, and that's $1. So you press 1, enter, down. Frequency of it. How many times consecutively do we have $1? Only once, which is usually the case in most problems. So you can save it by pressing enter and then the down arrow key, or just the down arrow key, because 1 is always the default. So I'm just pressing the down arrow key. Cash flow 02, that's the second one in the future. That's $2, right? 2, enter, down, and down again. Cash flow 03, the third cash flow in the future. And now you enter $83, right? The sum of the $3 dividend and the $80 present value of everything from that point on. So that's a total of $83. So you press 83, enter, down, and down again. What's cash flow 04? Nothing. We don't have it. We only have 3 cash flows in our simplified version of the problem, right? That's it. So now you just need to find the combined present value using 12% as the discount rate. You press NPV. I is the interest rate. You press 12. Save it by pressing enter, down arrow key, and compute. 61.57. It matches the answer we had when we used, sort of one by one finding individual present values and then summing them up. So the price you would pay for 1 share of stock with these estimated future dividends would be $61.57. You should not be paying any more than this, because if you're paying any more than $61.57, you're paying too much. You're paying more than what this share is worth, right? You will not get the money back. Okay, so again, I recommend you always use, 2 steps to solve any problem like this. Step 1 being, some sort of partial present value in the future, right? And it's always a growing perpetuity. And then step 2, cash flow keys. So step 1, present value of a growing perpetuity. Step 2, cash flow keys. Okay. So this problem was a little bit harder than the previous one. And now let's look at the next one.